screen? If you can't, yell at me or we can move you around somewhere. Morgan, you're probably in the worst spot.
I know, I think so. I can see it. I can see that though. So
Okay. All right. So we've talked a little bit about pieces behind the scene. We talked a little about some ethics pieces. Luckily, I did not have anybody plagiarize the ethics exam, which is a joke. We have had people do that before, so please don't go to Course Hero and try to find your ethics questions. So what I want to do is look at a couple of things in Python. We're going to show you how to run Python. So there are a huge number of ways to do it, and so we're going to experiment with some of them. We're going to start with the most basic model, and that is we're going to have you install the Python installation. Now, here in the lab, so you guys all should have this, so I'll probably make a separate video on how to install the Python lab. But on your own computer, we go to python.org. It's going to be our kind of like our home base for everything we're going to do. And if I go to downloads, it says, all right, here's a version 3.11.1. All right, perfect. Couple of notes. If you're not using anything past Windows 7, you can't run the latest versions, but anything in the 3 dot something will actually work for what we're doing. So I'm going to click on the download button, and it goes and says, oh, here's a download. Now, the problem in this lab for me is I have to go get permission to install stuff on this machine. So I will show you how to do it on another one, but literally, it's once I click install now, and it's going to pop up, and I'm going to say, oh, I can't do that. But we go through the default. So I will create a video of installing that on a virtual machine or something, just so you can see how quickly that goes. Once you have that installed, Python is ready to go, and it's handy. And the way we start it is the Windows key in Windows, obviously. And I type IDLE. Now you think, man, you probably should type Python, right? But what we're really doing is looking at something called the IDLE, the integrated desktop, blah, blah, blah. So, and it's got two modes, so I want to make sure we see those. So this is that interactive mode. So in this case, if I type print, and it's a function, so I have to enclose it in parentheses, it echoes it back to the screen. But I don't save the program from here. And most of the time, in fact, quite honestly, I rarely ever use this mode of IDLE. What I typically do is I will hit File, and I'll say New. When I come to New, notice that window looks like a text box or a text editor. It is a very limited text editor, I will say that. But for what we're going to begin with, it makes a really nice clean palette so we can start looking at them. So I'm going to type the same thing, print, hello. Now, I created a statement, and there's a couple things we're missing, and we'll talk about some other pieces in there. But right now, that's the one-line program. I don't have my name, I don't have the assignment number, I don't have anything else on it. I don't know if it runs or not, so I need to click Run. When I click Run, or F5, it says, oh, you have to save it. And so here's where it gets a little tricky, and I encourage you to find a space on a flash drive or on your home computer where you can save all of those at one spot. Because we have to save the files to both upload them in so I can look at them, and for you to be able to run them. So I'm going to click OK, and it's going to bring up our typical Save As box. And where it wants to save them to start with is inside of that Python folder. This is apparently version 3.9. I don't like that because it's harder to find. So typically what I'm going to do is on my documents or somewhere, I'm going to create a folder called Python Files, so I know where it's at. If you're working in multiple locations, this might be a great use of a flash drive just to store those. But in either case, you need to find a place that you can save them and store them. So really quickly, Python files are really nothing more than a text file, but with a different extension. So when I save it as a Python file, it's going to put the extension .py. That tells me it's a Python file, and so when I look at these, it's going to say, oh, it's a Python file. So here, all I have to do is put the name in here. And so this is hello world. Now, right there, I did something that is bad practice in a program. What's wrong with what I just did? Spaces are the devil. So spaces to our computer, it handles them sometimes. But what it really does is it has to put in another symbol for that space. So what I typically like to do is do that camel casing so that they're all one continuous string of characters. It doesn't break as much as it used to, but it still can cause some issues. So I'm going to call this hello world. I don't have to put the extension in. It does it automatically, except if you're on a Mac. So those of you that are going to install this on a Mac, for whatever reason on the Mac, maybe Macs are smarter and they don't need file extensions, but typically I'll see the file without a file extension. The problem is when I get onto a PC with it, then it makes it hard for me to grade it or to look at it. So notice I can save it as a text file, but I don't really want to. I have some there that are used for some other purposes. But if I save it as a text file and I .py, it would actually save it in the right format. And then notice I saved it and then it ran, and it then outputs it into my shell. So if I run it again, and I can do that over and over and over again. So this is our idle environment. This is where we're going to be at most of the time in this class. So one thing I can do. Let me see about that. All right. So we're going to be in this area, and we're going to have a place to save it and a place to run any of those programs. So if I look at my file folder now, so under Documents, I should have Python files. So these are the files that I've created in here. So this one is a Hello World program. That's the one we just created. I can actually run it from here, but I'll show you what happens. Come on, open. Yeah, it closes so fast on this one you don't even get to see that it's opening. And we'll show you why that's doing that. So I can also then, so these are actually just text files. So if I open those up, it's something in here we've used for something else. So sample of text or something that we're going to read and write to those files. So you need to make sure you save it, and we'll talk about the format you're going to save those in. In other words, how do I number them and what kind of other things do I need in them? So I want everybody to be comfortable going into idle and looking at this model. That's step one of our path today. So step two then. So I borrowed some of these things and just to look at them because other classes, other places all use this. So we want to look at how do we do things like print. So in our idle environment, you'll see that we do have a little bit of color coding. Now, we'll show you some other tools that make this even easier. But notice right up here, the very first thing they did in this statement is they put a hashtag symbol in, or as us old people call it, a pound symbol. And so we use that to document all of our. If I want to put in a line up here and I put a pound sign in, or a hash mark, whatever you want to call it, so that's where at the very beginning of the program you're going to put your name in there. And it also will document our process as we go. So the most important thing we're going to see is anything we put inside of this hashtag on a line, we can then document. We can also document at the end of the line, but I typically think this looks a little ugly, but we can. So anything in that red means it's not going to be displayed on screen. It's really just for us to see internally. So don't think about math. Most things that we do are functions. So we're sending out the item to something else. We don't have to rewrite the print command because it's already a built-in function. And so all of our functions always have that open and close parentheses. Well, you use that all the time in Excel. So if I'm in Excel, what do I have to do to put in my formulas? Don't I enclose them in a, yeah, it's a formula just like this. So print is our way we display it on the screen. So there are other ways we can do it. It's just the first function we're going to introduce you to. So we need to also talk about data types and some different pieces in here. So when I created ours here, we used a string. We said, hello world. And I had to enclose that in parentheses for that to work right. Notice it turned green and it made it really nice. But if I don't, if I just type hello, let me show you what happened. It doesn't know how to deal with that, and it's actually going to give us an error. Now, what it really thinks when it saw this then is I'm passing in something called hello, but it doesn't know what it is. So text strings get enclosed in quote marks. Pretty simple, but sometimes you get your brain spinning a little quicker, and it's hard to remember that. So comments. So we want those comments, and we use it in other languages. So there's typically different symbols, but that sharp symbol or pound symbol, so we want lots of comments, because what we want to do is we want to make sure that we document our code so it's self-documented. Variables. You guys remember X in algebra and different places where it stood for something? Well, we're going to do the same thing here. So placeholders are just really a way we store valuable, or variables are how we store data inside of our programming world. So couple of things about variables that we have to worry about. I like camel casing. Now, there are other ways to do it. You can use an underscore, but when you're in this programming world, you cannot put a space in there. If you put a space in there, that interpreter that runs our program is going to come along here and see a space and say, oh, that's the end of the command. So you can do an underscore. I prefer the camel casing. Now, I do something kind of weird though. I always start mine, so mine would look like this, because I always do lowercase to start, and then every word after that has a capital letter. Is it the end of the world? No. But a lot of companies have set up standards where these are the ways we're going to do variables. That just makes life easier for when you guys are looking at something else and you go, I understand that. So variables are case sensitive. No spaces. Any other kinds of special characters? Nope. The only other thing you can put in there is the underscore. I prefer the camel case, just the way my brain works. The other thing you can't use is a key word in Python, just because we don't want to confuse it. So right now the only function we know is print. We're probably not going to have a variable named print. That would be kind of silly. So we just want to, and it'll usually warn us and tell us that we can't do that. So we looked at all kinds of other data types in other languages. Well, the three that we're going to look at here with Python makes our life a little easier. So string, integer, and a float. So string, all we have to do is enclose it in quotes. We don't have to tell it how long it is. That's just a set of data that's a string. It's read. It doesn't get interpreted. It doesn't convert it to a number automatically. It's just a group of data that we have in there. Integers are just whole numbers. And then floats are a decimal number. Sometimes we know that we only need an integer. So if I'm going to count to 10, do I need decimals? No. And the amount of space decimals take up compared to floats is pretty significant. If we're only doing one number in a program, it probably doesn't make a lot of difference. But it's one way we can kind of performance enhance our code a little bit. So here we have an example of assigning a variable. So if the variable says this is a string of data, we don't actually have to tell Python what it is. So again, case sensitive, and it will typically interpret it on its own. So we'll start looking at some of these and what kind of things you can do. So we can run into this. So here we have num1 is equal to 2. But is that 2 as a numeric or is that 2 as a string? So num2 then is equal to a number. And if we try to just add those together, you're going to get an error that says, hey, I can't add a string and an integer or a float together automatically. But we can do some other things that are kind of interesting. So we can add messages together. So I'm going to go into Python and create one very similar to this. So I'm going to take my Hello World program and I'm going to add to it. So I'm going to add this is my first, and I'm going to do message 2. And then I can do message 3 is equal to 1 plus 2. So we don't know if this is even going to run yet. And the other thing we don't know is if we're going to get any output. So I'm going to put a print statement. Not a print statement, a print statement. And I'm going to say print message 3. All right. So when I run this, that should take in that variable. So this is my first, gets shoved into message 1. Variable gets shoved into message 2. And then it's going to put them together and print out a message for me. So I'm going to run this, and I'm just going to leave it in the same place. This is my first variable. Oh. But they're together. Notice that? There's no space in there. Ah. So I could put the space in here. That would certainly work. I could put it at the end of this, and that would work. Or maybe I try this. What do you think is going to happen there? So I added a blank space in. So I have 3 messages or 3 things all being combined. Let's see if that works. And notice, oh, it spread that out and I could put in my character that way. So that ability to add strings together is pretty handy because we can manipulate messages then really, really easily. So this assignment, very similar. One of the things that Python does is when we put a variable in, we can override it with something later on. So if I want to change a value, I can do that. I can add a new number into that box. So this example just says our variable called num was equal to 6, and then at some point we changed it and it became 8. So we can poke in new variables at any time. So this one here, very similar to what I did. We're just going to print message 1. So printing is actually pretty easy. It's practicing it over and over again that gets to be where we need to be there. So this is an interesting function. Type says, I want to know what is in this type of data. So I can say, use the type function to output a data type. So I know what type of data I have in a particular thing. So type function works the same way again. So let's talk about 3 different kinds of errors. So syntax, an error at runtime, or a logical error. So syntax means or refers to structure, how the rules are. So if we have anybody that has taken different languages, are there different rules for different languages? Yeah. And in fact, some of them don't always make sense. Do all the rules in English make sense, Ruben? No, Spanish is better, but less. No? Spanish is harder? So there's rules, and it happens to be if I type something wrong. So in this case, they forgot to put a colon after function. We haven't got there yet, but that's an error because the program won't know what to do without that. So if we do operations that are wrong, those are all syntax errors. Runtime says, oh, I'm going to do something that's wrong, and it's going to run forever. That typically is one of our errors, or it crashes in some other function. So the biggest issue is dividing by 0. We can't divide by 0. It's undefined, and it makes your computer cranky. The other problem is when we start doing loops, and we haven't yet, so don't panic. But if I take something like this statement here, and I'm just going to copy it real quick. So a loop in Python is really easy to do. So I'm just going to put this at the end of that. So while true. So notice that changed to orange, just to show us that we're doing some color coding. And so while something is true, and we don't even define what it is that's true in here, we just say while true. So there's no way for this program to ever end. So let me show you what it's going to do. And it's just going to sit there and print hello forever, because we don't have any way to stop it. So that's another example of a program that its logic is not quite right. So in this case, if you ever do something like that, you can just close this shell, or you can do Control-C to break it, and it will actually stop it where it's at. But this loop is what we call an infinite loop. So we also have this. So our code runs, but it doesn't give us what we think. Or even worse, it gives us what we think with very selected test data, but when we run it out in the wild, we end up with something different. So x equals 2 plus y, but it's actually x equals y minus 2. So these kinds of things we'll run into also, where your logic behind what you were creating is wrong. So it will throw out all of these kinds of errors and more. So type errors. So typically, if we try to combine 2 different types of operations. So if we do a string and a numeric of some sort, it tends to be an issue. Syntax, typically we've typed something wrong on a name. And then if we use a variable that's not been assigned a value, we'll also get this one. So, print functions can do all these kind of like silly old ASCII art. And we're going to want to talk about one more thing really quickly. So this, I think, is the fun part, because now we're going to allow it to take in data. So here we say name1 equals, so in other words, everything from that equals sign to the right gets shoved to the left, and we use an input statement. Input, enter your name. So it's got a string inside of it, that's what's going to display, and it's going to take whatever you typed in here and shove it into a version of name. So again, we can look at that. So let me take care of my problem child statement there. In fact, let's just do this. And then, so maybe we're going to use name is equal to, and then we're going to use our input. Please enter your name. And notice I put in a space there just to make it look a little better, and I'll show you what it looks like if we don't. Your age. I'm doing this one on purpose so we can look at something. Alright, so right now, I want to output welcome. And I can put multiple items in here. I'm just going to put a comma between it. Welcome, comma, name. And then I'm going to use the age in just a second, but I want to make sure this runs first. So I'm going to run it. And it says, hello, please enter your name. Please enter your age. And it says, welcome, Brett. Okay, perfect. Yeah, I know I got to do a little cleanup here because I didn't make welcome capital and things like that. But it takes my name and I can output it. So I can also do print. You are and I'm going to put, what do we call it, age. So now, I'm going to run the program again, and it's going to ask for my name and my age. Double check it. Great. That looks like it works. But I want to change this up a little more. I know that it can do a lot of different things. I want it to tell me how many hours old I am. Oh. So I'm going to create another variable called hours. And I'm going to say, okay, that's equal to age times, how do we figure out how many hours there are in a year? So there's 24 in a day, right? And 365 in a year. So now, this should give me hours is equal to, now, we're not going to exact dates, right? But it's just a rounding of that. All right, and so now I can print a statement that says, you are hours old. All right, make sure I don't have anything open. So now when I run this, let's see what happens. So name, age, whoa, what happened here? I may be old, but that doesn't look right, does it? Hmm. So why would it do it that way? That seems really odd, doesn't it?
Do you have to put lifespan back in?
No. Let's think about what it's actually doing here. It's a
I don't know if this is related. So when it comes to this, an attribute, right, is any just thing in there, right?
yes.
Okay, so what isn't it just repeating the attribute the number of times the equation says?
Yes. The reason it's doing that is anything we put into an input statement comes into Python as a string. So it doesn't know that this is really a number. And so what it's trying to do is it's multiplying this out. So whatever that number, this value is, it just repeated that string that many times. So I need another step in here, and I need to figure out how do I convert from one data type to another. So I know it's as a string, and I need it as, in this case, an integer would work really well, or a float. Either one's going to actually work. I'm most likely not going to type 54.3 years old. So here's what I'm going to do. So I can convert it in the fly, but I typically like to do it in a different statement, just to make it a little clearer. So age equals let's do age. So again, it takes the data on the right and shoves it into the left. So originally this was as a string. I'm converting it to an integer in this case. And then I'm able to run this. So I'm going to run this again and see what happens. See if that fixed our problem. All right. Ah, so I am 473,040 hours old. So it's just something to be aware of. And a lot of times it's actually just going to crash and tell you there's a type mismatch. In this case, because that's a function we can do with something, so I could come in here and print this repeated 72 times, but I'm not going to. But so I have to be aware of those different types of inputs. So everything comes in as a string, and if I'm going to convert it and use it for something, I have to what we call cast it into a different type of variable. So this is just the easiest way. There's a float one. We can take it back to a string if we need to. But typically, we have to make sure we do something like this. And I just put this in a separate line. You can actually do that. You can actually do this in this right here. You could actually do the same thing. You could say int. And that would actually work the same way. And I think that's what you were mentioning. But for trying to understand what's going on, I typically put it in a separate statement just so I see what's going on. A little bit of white space at this point isn't going to cause us a lot of grief. All right, so let's go back and look at Python quickly in our course. So there is an activity. So activity 1.1. Yeah, because we're going to try some things, I stole this very liberally and said, all right, we're going to show you that Python can work in a lot of different environments. So for when you see this, I want you to say, open your IDE. So they're not even showing just the Python IDE, that you can use it in all different kinds of things, Visual Studio if you want to. We're going to just open it in Python's idle. And here's what your name is going to be. So, whatever this one is, so this is Unit 1, Module 1, Activity 1. So, Unit 1, Module 1, Activity 1, and then your initials. So the programs are also going to have your name, but when I sort file names, it's kind of nice to have that idea up there. And I don't have 40 of them with the same name, which causes other things. All right. So our first program is write code for your first program, hello world, then run and test it. Okay. Write a second line of code to show the following message. Hello program, then test and run your code. So, comments are for us to read. They won't execute them. Make sure you put them at the top. Should have at the beginning, program name, when you revised it, your date, and your name in here. Okay? So, that way, I can see who it is, when you revised it. So, this one we can do really, really easily. So, I think we should do this one together.
Yes.
Perfect. All right. Program assignment 1. So I'm going to go to my.
Do I have to close this?
You can. I'm just going to close all mine out just to make life
It
easier.
looks okay.
Oh, they're all gone now. Okay. So the hardest thing is kind of remember this order of things. So I'm going to open idle, IDLE, and it's going to pop up here. We know that this code is going to be one we're going to have to save, so I'm going to type File New. And I'm going to move over on the other side of the screen just to see. So this one says we have a couple of things. So first of all, I'm always going to start out with my comment code so I know what's in there. So this program is Unit 1, and then Module 1, so we can keep track of it, and then Activity 1. Perfect. So now I know what activity it is. Now I'm going to do another line. Yep. This program, actually I'm going to do kind of a what is this program supposed to do? This program prints hello world. So then I want your name. So, and then whatever the date is. So the date is the, is it really? I will say I can't get used to writing 2023 yet. Alright, so now we're going to write our code. So,
Can you zoom in on that?
can I zoom in on this?
Yeah, just a little bit.
Let me see if I can make that. Let's see if I can make this bigger. No. Let me pause this while I play around with it. Alright, I try to make this a little bigger so we can see that. Always yell at me or ask for these kinds of things, and I can usually accommodate them. So I'm going to move this out of the way. So we want to make a statement that says, hello world. So print. And then we hope that works. So the first thing I'm going to do is I'm going to run it. And when I run it, it's going to force me to save it. And I typically do that. You can also save it as you go. I know in documents I have one called Python folders. So hello world 2, whatever it happens to be. So now I've saved that file. And when I run it, oh look, it actually works. Okay, so my next step then is the second line in the code to say hello programmer. So we need to add another line in there, so we can simply come in and go print we get to the end of this. Now I'm going to run it again. And hopefully it works. Oh, what have I done? Alright, there we go. So, program runs. We've saved it. We have our name in it. Alright, so let's go back into this assignment then, and let's turn it in. So, in this particular assignment, did not show my turning on? Alright, that's interesting. Why did it not do that? File upload only. Okay. Why did it not? Is it? Oh, maybe it's just because I'm in here as an instructor. Okay. Well, that's probably. Oh, okay. Yeah. So as soon as I go to the, so upload, and that's where it's important to know where my file is stored at. So I choose a file. So in this case, I'm going to go to Documents, Python Files, and then Hello World 2. Now, the weird thing, it probably will not, once you have submitted it, it will not typically show it to you as a preview. The Word files and everything it shows as a preview, I don't think it can handle Python as a preview. So, do we do the first quiz together? Yeah. All right. Modules. First quiz. Let's take a look at it together. What time is it? Okay. So I want to take the quiz. So Hello World is a specialized program specifically for Python. False. We use it in about every language. How do you know if your code is correct? Well, we could read it and try to see if we know if it's correct. We could view it. But the only way to really be sure is if we run it. Alright, this course typically covers Python 3. There are versions of Python version 2 that are still out there, but most people have moved on to version 3.
When it comes to Python version 2, do you happen to know why Python 3.9 it says it invalidated Windows 7 after that point? Do you ever know what changed from Windows 7 to 8?
I really don't. I'm going to guess it's something pretty minor. But
Okay.
Any of the versions, so if you have an older computer, any version of this above 3 will work. So, and I can show you where you can download older versions. I just want to make sure you don't run version 2, because there are some substantial differences. There was a big fork. And 2 still continued some development for a while, and when 3 came out, there was enough code out there in existence in version 2, but there's some substantial differences in how they operate, and so version 3 is what we need. And then what is a valid Python code comment? So use comments to provide functions of code? Yeah. Huh. Comments can provide instructions for other developers. To make code easier to update. Yeah. Warnings can be placed in there. So I will tell you the little trick on that. Did I really? It didn't like my answer. It should be all of them when I built that, so I'm not sure why it didn't like that. I'll have to go look. Alright, I will fix that one real quick. But all of those things are, oh, it's got the slash, never mind, I see what I did. I didn't see the slash in there.
So it's going to be the 3?
Yeah, it should be the first 3. Yeah, I screwed up. Look at that. I will fix it for everybody that missed that. Alright, so yeah, it's because of the slash, and I just skipped right over it when I was reading it. So you'll notice that these have a single radio button. If I have square boxes, I could typically have more than one comment. So But I have the ability to do something you guys don't, and that is I can reset my student. Oh, now his quiz went away. Yeah, you can actually do it twice, I believe. Yeah, I have it set up. All right, so
So this is 3 and 4 combined, so all of this is for next week too?
yes, so there is a. Well, there's more. We're going to see how far we get, because I'd like to get through all of these because I'm sure we will. We will make it through all of this. All right, leave student view. Because there's a few more of them, but I want to kind of take it in steps so people don't just rush through and everything. So the next one we're going to start then is activity 1-2. So I'm going to open it. We'll probably not get to it early enough, but what we're going to do here is we're going to do some additional things. So we're going to combine strings, we're going to add numbers, troubleshoot errors, and we're going to do what we call ASCII art or character art. So the instructions get a little tougher on this one. So that's where I want to start on Thursday is with the 1.2. Yeah. And we will actually work through this assignment as we go through there, and so we'll work through a couple of those. So that is where we're going to start on Thursday.